everyone, myself and our dear classmates. Today we are here to present a group presentation on the topic of purine biosynthesis, and we are from BMLT second year and our subject is metabolic biochemistry. And I will ask my dear fellow mates to introduction themselves.
Good morning, I am Pratik. With my presentation.
Good afternoon, myself Anuragash. I am BMT second year.
My name is Surabaya. I am from BMT second.
So now I will start by purine biosynthesis. First we will discuss about what is purine biosynthesis. Purine biosynthesis is a multi-step catalyzed enzyme that will use where substrate will be converted into a complex product. Now the liver will be the major site of purine biosynthesis. Brain and erythrocytes cannot produce purine in de novo pathway, but it can produce in salvage pathway. We will discuss about de novo pathway. So what is de novo pathway? De novo pathway refers to the synthesis of complex molecules from the simple molecules. And there will be the product that is obtained in the last, that is inosine monophosphate, the parent purine, that will be the which will form other purine nucleotide can be synthesized in that, and there will be one pre-existing purine that will be built, that is ribose 5-phosphate. Now we will discuss about de novo pathway. In that we can see the ribose phosphate in the first. In that it will change into 5-phosphoribosal pyrophosphate in the presence of PRPP synthetase enzyme, and the ATP will use, and it will convert into 5-phosphoribosal pyrophosphate. Then in next it will change into beta-phosphoribosal amide, and the enzyme that will use, that is PRPP glutamine amidotransferase, and the glutamine will change into glutamate. Then it will beta-phosphoribosal amide will change into glycine amide ribosal phosphate, and the enzyme that will be used, that is the synthetase enzyme, and the glycine will change into ADP plus PY, because there will be a amide in the last. In the glycine amide it will be changed into amide ribosal 5-phosphate. In that, after that we will change the glycine amide ribosal 5-phosphate into formal glycine amide ribosal 5-phosphate, and the enzyme that will be used, that is the formal transferase. So as we can see, there will be formal glycine amide ribosal phosphate. The formal group will come from the N5 plus N10 methynyl THF. Now as we can see, THF, that it means tetrahydrofolate. Now I will hand over to Pratik to continue the presentation.
Thank you, Pratik. Now, here we go. The formal glycinamide ribosal 5-phosphate is now converted into formal glycinate amide ribosal 5-phosphate by using the synthetase enzyme, where it uses glutamine. Then the formal glycinamide ribosal 5-phosphate is now converted into 5-aminomide ribosal 5-phosphate, where it uses again the synthesis enzyme, where the ATP changes into ADP. Now the 5-aminomidazole ribosal 5-phosphate is now converted into 5-aminomidazole carboxylate ribosyl 5-phosphate by using the carboxylase enzyme, where the pseudo is used. Now the 5-amino carboxylate ribosyl 5-phosphate is now converted into 5-amino amidazole 4-succinyl carboxylamide ribosyl 5-phosphate by using the synthetase enzyme, where it uses the aspirate plus ATP. Then it again converts into 5-amino diazole, 4-succinyl carboxylamide, ribosyl 5-phosphate. Then it converts into 5-aminomide zole, 4-carboxylamide ribosyl 5-phosphate. By using the adenosuccinylase enzyme, by using the fumarate. Now I hand over the upcoming presentation to Anurag.
Thank you, Pradeep. Now, 5-amide imidazole, 4-carboxylamide ribosyl 5-phosphate are converted into 5-formyl-amide imidazole, 4-carboxylamide ribosyl 5-phosphate in presence of formyl transferase enzyme, where it and 10 methylate EHF are used. Then 5-formyl-amide imidazole, 4-carboxylamide ribosyl 5-phosphate are converted into inosine monophosphate in presence of cyclohydrolase enzyme. Here it removal of water molecule. Now I request to PhD continue with the next part.
Now, as we can see, there is the inosine monophosphate product has already obtained. There will be the synthesis of AMP and GMP from inosine monophosphate. As we can see, there is on inosine monophosphate, there will directly convert into xanthosine monophosphate with the help of an enzyme that is IMP dehydrogenase, and the one energy formation will be there because of NAD plus and H2O, and there will be energy production, that is NADH. Then xanthosine monophosphate will directly convert into guanosine monophosphate, the GMP. It will the enzyme that will be used, that is GMP synthetase, and glutamate will use, that will change into glutamate. Then we can see we have to make the product of adenosine monophosphate. So for that, inosine monophosphate will directly change into adenyl succinate with the presence of enzyme, that is adenyl succinate synthetase, and the asparated and the GTP1 energy source it will be used, and it will form adenyl succinate. Then it will change into adenosine monophosphate with the presence of adenyl succinase with the substrate of fumarate. That's all for our presentation. Thank you for your precious time, and I hope that you found this presentation very useful.